Hi everyone, welcome to my video. In this video, I'm going to show you how to designing over-the-top or OTT platform architecture. But our objective is not actually to create the best architecture possible. Instead, I want to show you the thought process behind any good system architecture. But before we begin, I need you to understand that the final architecture is unproven and never been implemented on any live production environment. So the final architecture might be unsafe, it may be unworkable. So please take it with grain of salt. Before we start to designing anything, the first thing that we need to do is to understand the system requirements. To make it simple, in this video, we're gonna just create a very straightforward OTT surface with domain user flow, something like this. User go on the platform, they are served videos and they watch them. It's pretty straightforward, right? But to make things more interesting, we gonna need to create platform recommendation system, which means the platform should have access to a lot of user activity data and able to process them. Why I put this? Because this kind of scenario is actually common in real life and it's really hard to answer. By showing you this, I hope in the future when you find similar problem, you have good understanding or at least you have reference. But we still not gonna designing other feature like order services, payment services, or even authentication services. We are just gonna focus on designing the core streaming service. Okay? After we understand the requirements, next, what we need to do is actually doing some research. Let's just pretend we have done research. So uh, after we after we done the research, we found out five findings that very relevant to the system. First is the system will offer roughly 1,000 videos, and second, maybe based on competitor analysis or maybe based on a previous experience, there's approximately one only 100 videos are actually being watched by user per their lifetime. So only 10% of total content is actually being watched. The third findings is we can assume an average of video length is 1 hour. And each video will have standard definition and high definition. Per hour, standard definition will take up about 5 gigabytes of space, while high definition will take up about 10 gigabytes. So approximately, only 5% of total users streaming concurrently during peak hours. So now we have our initial findings and we understand the requirements. Next, what we need to do is we need to create a plan of how we're gonna approach, of how we're gonna, solve all of our problems. First, what we need to do is answer the question how much storage we need and what kind of storage that we're gonna use. Second, how we gonna deliver our content. Third, how we gonna create the recommendation engine. Okay, let's answer the first question, which is how much storage we need for video content. To be able to answer that, let's do a quick storage capacity calculation. Okay, so 1 hour is average for all the video, and we need 5 gigabytes for SD and 10 gigabyte for HD. Sum up, we need 15 gigabytes per video. And we have 1,000 videos, both stored in SD and HD. So, based on all of those data, we found out that we need 15 terabyte of storage for video content. The size is relatively a n- not huge, but also not small. Because it's not that huge, we don't need to do any special treatment for this data. We can just store them on blob storage, something like AWS S3 or Google Cloud Storage. Next, after we answer how much storage we need for video contents, now we need to answer how much storage we need for metadata. First is video metadata storage capacity calculation. We know we have 1,000 videos, and let's assume that we need 10 kilobytes that size, 10 kilobyte space for each video. So we approximately need 0.01 gigabytes. It's very small, so we don't need to do anything about the video metadata. Next is user metadata. So we have 10 million users, and we have 100 videos watched per user per lifetime. And let's assume we need 10 bytes for metadata size. So we need 10 gigabyte uh, of space to store all this metadata. So it's not that big. So we don't need to do any special treatment for this. So we can just store them into maybe SQL database like MySQL or Postgres. Why we don't use NoSQL? Because basically our metadata is pretty straightforward, and then maybe need to do a query, and I think it's always better if we use uh, a simpler technology instead of just go full blown NoSQL and have headache with all the indexes or sharding. Let's go to the second question: video content delivery. Before we can answer the question how we gonna deliver video to the user, first we need to do bandwidth capacity calculation. So as we may already know, we have 10 million of total users, and 5% of total users streaming concurrently during peak hours. And we have, you know, the biggest size is HD, and HD take to transfer HD to the user, we need approximately 2.8 megabyte per second. And we calculate all those three data. We found out we need 1.4 terabyte per second. And it's really huge. We need to do something about this. So what we need to do is we need to implement a content delivery network. Why? Because CDN or content delivery network will help to deliver video content across the globe with low latency, since they have a closer point of presence to the users, and it's basically uh, available around the world. But there's another problem. Point of presence cannot keep the entirety of videos, which is 15 terabytes, in cache. To solve this, we can have an external service that periodically repopulates CDN POPS with the most important content only, maybe the most likely to be watched by a user in particular region. And actually, to to answer this question even further and to minimize cost of content delivery, working together with internet service provider and use their internet exchange point is also recommended. Why? Because by working with them, we can have lower cost of network transportation fee. So if we can find a good ISP to work with, it's gonna be much better. Now we need to answer the hardest question: recommendation engine. First, we need to answer the question how we gonna uh, score video and how we gonna track user activity. So, how to populate the data to be feed for the best to be fit into recommendation system. First, we have two options. First is a by using user feedback, like let user to give stars or like dislike. Second, to track and compute the real user activity, and I prefer this one. Why? Because by implementing this service, we don't need user uh, to do like manual activity like giving stars or click like or dislike, since maybe user have a, a bias towards maybe some actors or actor, yeah, to, bias towards some movie, and maybe uh they just uh misclick the button. So I always prefer the the weighting or scoring based on real user activity. Next, after we decided how we're gonna populate the data, next how we need to decide it. We need to decide how to compute video score. So maybe after doing some discussion, we decided uh, to do this following. First, when a user watch full video or at least 80% of the total video, then the system will assume the user liked the video and will give high score for the video. And vice versa, if a user just only watch like 10 seconds of the video and choose to click another video, we will give a lower, maybe low score for that video. And then system can give recommendation based on video score calculation, cross-reference with video similarity. Example like similar genre or title. The third one, system can also give recommendation based on other users' video scores with similar profile. Okay, now we have a clear plan how to compute video score. So we need to create the users uh, tracking activity schema. We're gonna use simple JSON uh, data schema, something like this. So we're gonna store user ID, video ID, and event like play, pause, stop, or maybe uh, forward or backward, something like this, something like that. Now after we decided how we gonna track users activity, next we need to uh, crunch the data, and then we need to make the data representable and uh, processable by machine learning. So b- to be able to do that, we need to implement MapReduce. First, we need to implement our map function. Our map function will aggregate logs or activity user logs based on user ID and return intermediary key value pairs indexed set on each user ID, pointing to the list of tuples with video IDs and relevant events. It sounds hard, but actually it's simple. We're just gonna create the previous user activity schema into something like this: user ID, uh, and then we're gonna aggregate activity, something like this on, and then we're gonna put a video ID. It's much simpler and much readable. Okay, after that, after we implement map of function, we're gonna implement reduce function. Our reduce function could return key value pairs for each combination of user ID and video ID, pointing to a computed score for that user or video pair. The computed score will be generated by a machine learning. So yeah, we're gonna use machine learning to compute the score. But we're not gonna discuss about the detail of machine learning implementation. Let's just assume the machine learning works and we have it ready somewhere. So our final design will be something like this. First, admin upload video into blob storage, S3 or Google Cloud Service. Sorry, Google Cloud Storage. And then the video will be forwarded to point of presence or internet exchange provider. Sorry, internet exchange point, cache populator. And when particular users from a particular region, example like region A, trying to access video, it will be served by this a CDN or EXP or Internet Exchange Point that provided by EISP. And let's assume we have like a client app. This client app then will need to access the DNS region resolver because maybe we implementing we decided to enable to use domain name instead of IP. So we can implement DNS region resolver or route balancer. This DNS then will uh, decided which server load balancer that gonna serve the request. Let's assume this load balancer is gonna uh, serve the request, and then load balancer also can uh, do maybe some sort of hash algorithm to decide which API server that actually available or maybe not busy to serve the request, and API server will access RDBMS database for user metadata and video metadata, and for storing and receiving or getting user activity, these API servers should access HDFS cluster, and this in this HDFS cluster, map redis job and video scoring from machine learning already been uh, already been executed. So we have lots of user activity data. So then uh, for the next request, instead of accessing HDFS or IDFS, all these RPS servers can access Redis cache. So I think this is what we're gonna do. We're gonna have blob storage and CDN or maybe IXP or maybe both. And we're gonna have load balancer for DNS, and of course we're gonna have reverse proxy load balancer, and we're gonna have several IPS server because we need 1.4 terabytes. It's very, very large, so we're gonna need multiple server. And to make our system latency low, we implement cache, and to enable a huge data processing, we implement MapReduce job with video scoring that generated from machine learning. So I think I'm pretty happy with this design, but we still have problems. Actually, we didn't cover how to implement adaptive bitrate or IBR and convert video format automatically from 4K to HD to SD to 1080p and 720p and 480p. this is important because we need to accommodate a low bandwidth or small device like smartphone. We didn't cover this. And actually, we didn't cover how to encrypt video and secure video. We didn't cover how to block video based on user region and many more. But life as an engineer or innovator, always challenging and fun. And let's keep this problem for our future self. Okay? Okay, that's all. If you have a question, you can drop me an email on or call me or drop me WhatsApp message. This is my phone number. Thank you. See you on the next one. Bye.